All right, this is chapter 3, section 2, using parallel lines with transversals. Okay, so we've got a few postulates and theorems. So what these postulates and theorems say that if two parallel lines are cut by a transversal, so I'm going to go ahead and draw an image. Two parallel lines. Again, we know they're parallel by those two arrowheads. If they're cut by transversal, corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. And consecutive interior angles are supplementary. And those are all the postulate and theorem names in parentheses next to them. So we've got 4 of them, okay? So let's go ahead and apply each of these. So corresponding angles are congruent. So let's look at our image, and we're going to go ahead and label each of the angles. So this will be angle 1, this will be angle 2, 3, 4, 5, 6, 7, and 8. Okay, so if we label angle 1 with a red angle mark, okay, the corresponding angle to angle 1 would be angle 5. So angle 5 must be the same length as angle 1. Okay. The alternate interior angles theorem says that alternate interior angles are congruent. So if angle 5 is the red mark, okay, then the alternate interior angle to angle 5 is angle 4. So this one also has to be the same length. Okay? The alternate exterior angle theorem states that if 1 is that length, then also 8 has to be that length because they are congruent. So all 4 of those angles are the same length. So if we were to be given 2, we could also say 2, 3, 6, and 7 would all be the same length as well. It applies both ways. Okay, so let's go ahead and change our color and draw 2 angle marks for each of those. Okay, and consecutive interior angles are supplementary. So all that's saying is there are 2 interior angles. So angle 4 plus angle 6 is going to be 180 because they're same side interior, and angles 3 and angle 5 will equal 180. And this should be measure. Okay, the measure of all those angles with their pair equals 180. Okay, all right. Now we're going to go ahead and apply these theorems in our next slide. All right, so example 1, find the measure of each angle. Okay, now this did print kind of poorly, so go ahead and cross out the 130, cross out the 7, cross out the 6. The 6 will go here, the 6 will go here, the 130 will go here, and the 7 will go there. Okay, so the measure of angle 1, so this is 130. Okay, so let's go ahead and figure out the rest of the angles. So if we know that this angle right here is 130 degrees, okay, we can start filling in the other angles. So let's start with our first theorem. Our first theorem on the previous slide said that corresponding angles are congruent. So the angle that is corresponding to 130, this 130 is the 3. So the measure of angle 3 must be 130 degrees. Okay? Now, the second theorem stated that alternate interior angles are congruent. Okay? And I see that the alternate interior angle to angle 3 is angle 5. So this one must also be 130. Okay? So let's go ahead and fill in angle 5 is 130. Now that we know both of those, our third theorem says that alternate exterior angles are congruent. So this 130 here and this 2 are congruent. So 130 degrees. Okay. And then lastly, we know that consecutive interior angles, so if this line is our transversal in red, okay, this line is our transversal, staying on the same side of the transversal and being interior, that would be 3 and 6. Those will add up to 180. So will 5 and 4, okay? So let's go ahead and put 130 plus the measure of angle 6 equals 180. So then all we have to do is subtract 130 from both sides. So the measure of angle 6 is now 50 degrees. So we know that measure of angle 6 is 50. Same thing for this one. So the measure of angle 4 is going to be 180 degrees minus the 130, which was the measure of angle 5. So the measure of angle 4 is also 50 degrees. Okay? And then the measure of angle 7. Well, if 6 is 50, 7 is a vertical angle to 6, so 7 must also be 50. And then same thing with 1. 1 must also be equal to 50. And then the measure of angle, oh, I'm sorry, I put 8. That should not be 50. This is going to be 50, sorry. The measure of angle 8, well, obviously, if it has a right angle mark, then that one has to be 90 degrees. All right. Okay, so find the missing values. So whenever we are given some variables and some angles that we know, we always want to start with the angle that we know. In this case, we know that this angle is 110 degrees, okay? Now, these two are parallel, and so are these two. So knowing that, I'm going to use the double parallel line, so that would be this one and this one, and cut by the transversal that I'm going to draw with a black line, okay? So our black line is our transversal. So in that case, the 110 directly corresponds to the 2z that I see here. So those two are corresponding angles. And since the two lines that are cut by the transversal are parallel, then we can say that they are equivalent. So this 110 is going to be equal to 2z, okay? Now, in order to solve for z, we just divide both sides by 2. This will cancel, and we're going to be left with z equals 55 degrees. Okay, knowing that z is 55 degrees, or that this whole angle is 110 degrees, now we can figure out 2y. So now things change though. So our transversal is no longer this line, the black line. Our transversal is now the yellow line that we had before. So these two are the parallel lines, and our transversal is now this line. So how do we compare 2y and 2z? They are what we call consecutive interior angles. Interior. Okay, so 2y plus 2z will equal 180. Now we know what z is. Z is 55, so 2y plus 2 times 55 equals 180. So now we just write 2y plus 110 equals 180. We subtract 110 from both sides. 2y equals 70. divide by 2, y equals 35 degrees. So y equals 35 degrees. So 2y would be 70. So this whole angle is 70 degrees. And x, if we look at this being our transversal and the two in red, which we know are parallel, being the two lines that are cut by it, then they are corresponding angles, the 70 degrees and the x, okay? So I'm going to write this down here, corresponding angles. So that 70 degrees must be equal to x. You could have wrote it as 2y equals x and just plugged in y equals 35. But I know that that angle must be 70 degrees, so I'm just going to say 70 equals x. And so 70 degrees. All right? So again, you want to start with the angle that you know. In this case, it was 110. And then we're filling in the variables as we go along. Okay, so again, a real world problem. So when sunlight enters a drop of rain, different colors of light leave the drop at different angles. This process is what makes a rainbow. For violet light, the measure of angle 2 equals 40 degrees, okay? So what is the measure of angle 1, and how do you know? Well, let's look at what the problem gives us. I see here that there are these two arrow marks, so that means that those two yellow lines are parallel. Our transversal is this purple line that I'm going to circle in blue. That's our transversal. So now the comparison between angle 2 and angle 1 is they're both interior and they are on opposite sides of the transversal. So I can say that they are alternate interior angles. And since the two lines that are cut by the transversal are parallel, we can apply the alternate interior angle theorem. Interior angle theorem, which states that the measure of angle 2 will be equal to the measure of angle 1 because they're congruent. So therefore 40 equals the measure of angle 1, and that's our answer. All right, example 4, give a two-column proof. So given that P is perpendicular to Q, I'm sorry, not perpendicular, parallel to Q, prove that angle 1 is congruent with angle 2. So that's this one being congruent with this one. Well, this is going to be a really easy proof. So let's start by saying that, or let's start by drawing our statements and reasons chart for our two-column proof. P perpendicular to Q, sorry, I keep saying perpendicular, it's parallel, P parallel to Q. And so that is our given. Next, well, how do we know that they're equal? Well, they're alternate interior angles. So measure of angle 1 equals the measure of angle 2 because of the, I'm sorry, no, they should be congruent. Rewrite that. Angle 1 is congruent to angle 2 by the alternate interior angle theorem. Okay, now some of the homework assignments will ask you to prove, you will use a two-column proof and prove this without saying that, without using the alternate interior angle theorem. So let's do an example of that, okay? So I'm gonna erase what I have right here and we're gonna start over. We're not going to use the alternate interior angle theorem. If you use that in the future, that is fine, but I'm just gonna show you an example. So P parallel to Q, that's given, okay? Well, if that's given, we know that 3 has to be equal to 1 by corresponding angle theorem. So let's put angle 1 is congruent to angle 3 by the corresponding angle theorem. And 3 is congruent to 2. Angle 3 is congruent to 2. Why? Because of the vertical angle theorem. Okay, because remember, vertical angles are congruent. And now we can jump to the conclusion that angle 1 is congruent to angle 2 by the transverse property of equality. And you might be wondering, well, how did you get there? Well, I see that angle 3 is congruent to both of them. So by the transverse property of equality, you can take out the middleman, and angle 1 is congruent to angle 2. This is your homework. Good luck.